Welcome back to Unit 1 Common Core. This is Part 5, but we're just going to start using letters. So this is Part E of this series. But before we begin, a reason why I want you to close your mouth or get a tissue when you sneeze. Alright, that was gross. So let's begin, shall we? Now, while most of you know lesser or greater than, more than a few students could use a slight refresher. So this is less than. Less than simply means less than something else. Now, how do you remember? Well, the L looks like a tilted L. Now, I'm sure no one's ever done this to you before. Nice little L there, but L for less than. Just turn the L. See, and the other side would be obviously for greater than. So 3 is less than 9. No big deal. Well, the other one is greater than. Obviously means more than. So 7 is greater than 2. A quick way to remember also, imagine that lesser greater than sign is like an alligator's mouth. The alligator goes towards the larger bite. Now positive numbers are easy. So you have 3 is greater than 1 and 7 is less than 12. And remember, these larger the negative value, the less the value. In other words, negative 4 is greater than negative 6. Now why? Because I'd rather owe $4 than owing $6. So if you have to go into negative, you'd rather owe less than owe more. And the same way, negative 8 is less than negative 1 because you're worse off if you owe $8 than if you only owe $1. But decimals can be a little tricky. First, you have 6.5 and 6.4, which is larger. Well, if the whole number's the same, both are 6s, we go to the decimal to determine the higher value. In other words, okay, both are 6s, and then the next up is a 5 versus a 4, and whichever number's bigger wins. 5 is bigger than 4, so 6.5 is larger. So the alligator goes towards that bigger bite. 6.5 is greater than 6.4. For a money example, you have 6.5 versus 6.4. Think of 6.5 as 650, 6.4 is 640. Obviously, $6.50 is more than 640. But it is always one value at a time. So in other words, 8.234 versus 8.7. Both start off with an 8, so they're equal so far. Even though there's 3 numbers here, don't look at it as 234. Look at it as 2 versus a 7. Since 7 is bigger, 7 wins. Remember, it goes one at a time. Even though 8.234 is more decimal numbers, the 7 beats the 2 in the first round. Remember the card game war? Very quick explanation. You go ahead, split the deck up into half. You both flip up a card. Whoever's got the bigger card takes those 2. You flip up again. The next person takes the next 2, so on and so forth. The only thing is, if you both pull up the same card, let's say you both pull up a 7, then you have to lay 3 cards down for each of you, and then you flip the next card up, and the winner takes all 8 cards. This is a way for allowing some players to take, the higher cards of other players, and so on. It's back when games were pretty rare, so these are much funner games today. Anywho, also remember that a negative is always less than a positive, so negative 3,234 is less than 3.7, because even though 3,234 is a bigger number, because it's negative, it's a smaller value. Same as this here, 21 is greater than negative 12,000 some, and 23 is greater than negative 12, etc. You try. Put in the correct lesser greater than. Go ahead, take a look at these 3, and go. Let's see how you did. I hope you know that 3.234 is less than 3.7 because 7 is bigger than 2. This is greater than because this number is greater than any positive, greater than any negative. And this here is going to be less than because 0 is less than 5. Hope you did well. Skills practice 1.3, lesser greater than. So go ahead, take a look. Pause it this time. Let's see how you did. And of course, yes, you can turn in the paper for extra credit, etc. Okay, so less than, greater than, less than. You probably get all 3. Now for our next section, we're going to talk about spiral review. What spiral review is as I've shown you something in the past with this video series, sometimes you might have done it once and forgotten or may need a little more practice. What spiral review does is we come around and try a skill again, but we add more to it. And our victim of the day is, of course, fractions. Now, let's start with a visual. If you take a look at this pizza here, it would normally be an 8-piece pizza. What I've done though is I've highlighted a piece of pizza that has been missing. Now later on in this video I call it pizza or pizza pie or just pie. Know that I'm just means the same thing, a pizza or pizza pie. Now with a fraction, remember you have a top and a bottom, but I want to add to that and say, okay, the top's part and the bottom is the whole, part or whole or part or total. So I had 8 out of 8 and now I'm taking one away. So there's 8 full pieces at first. The 8 goes in the bottom because that again is the total or the whole. 1 piece was taken, so 7 are left. So in the fraction, the part that's left is 7 on top, so it's 7 out of 8. Again, a quick spiral review. 7 out of 8, 7/8 of the pizza is left. Another way to look at it, there are 7 parts left, 8 total, so 7 out of 8, no problem. 0.875 is our decimal. So if I wanted to find the decimal, remember top divided by bottom. So you have 0.875 pizza left out of the entire one as a whole. Now remember, you turn that into a fraction, you simply multiply it by 100. So you take 7/8 times 7/8 or 0.875 times 100, and you get 87.5%, meaning there's still 87.5% of pizza left from that one piece from that one whole pizza that it was. Oh, and if 7/8 of the pizza is left, how much was taken? In other words, what's missing? Well, yeah, everyone's going to say 1/8, and you're right, but let me show you why. What I want you to do, the original pizza had 8 pieces, so it's 8 out of 8, because before I touched it, it was 8 out of 8. Then, when you take one away, or in this case we're saying that there's 7 left, how many were taken? Take 8 minus 7, and that leaves 1 out of 8, or 1/8 was how much was taken. We'll do more of that later in another spiral swing around later when we start adding and subtracting fractions. I know, yay, very happy. Now all I want you to do is count the colored pieces and tell me what the fraction is every time. So let me move these down so you can see them in one whole group there. Go ahead at this time, pause the video, and write down your answers. Let's see how you did. I have 1, 2, 3, 4 colored pieces out of an entire 7. So there's 4/7 of the pieces that are colored in. Here I have 1 piece that's colored out of a total of 3, so 1/3. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 purple out of 10 total. And here I have 1, 2, 3, 4, 5, 6. I have 2 purple out of 6, or 1/3, which we will be covering shortly. Skills practice, state the fraction. So here on your paper that you'll have with you tomorrow will be these fractions. Go ahead and write down your answer at this time. Let's see how you did. So what we have here, I counted 5 pieces out of a total of 15, and I'm going to show you in a few minutes how to make that 1/3. Here I have 2 colored pieces out of 5. Here I have 2 out of 6. I'm going to also make that 1/3. You'll be seeing that soon. Here I counted 12 colored pieces out of 16, so I have 3 out of 4. Notice the nice thing that for the rest of the year, when you're asked what a division problem is, you can simply make it a fraction. In other words, if I say, well, what's 9 divided by 11? You can just say, oh, 9 out of 11ths, or 9/11ths, and that would be right. So go ahead at this time and with the skills practice, which you'll have on paper tomorrow, solve by keeping it in a fraction. So take these 5 and go ahead and make them into a fraction. Let's see how you did. Well, 9 divided by 17 is 9 over 17. This over this, this over this. You get the idea. All we're doing is we're making them into fractions. Now here's the hard part. 9 divided by 24. Okay. Some of you are going to know it's 3/8, but not everyone in this class. Let's show you how. We're going to start easy, but we're going to make them harder. There will be a reason why, I promise, in a few minutes. I will prove this to you. Well, 9 over 24. Okay, you might be able to divide it down, you might not. Well, how do you know? Here's what I'm going to ask you to do. We have to decide we can divide both the top and bottom by. You might remember that from a previous video. What I want you to do is try to divide by 2, 3, 5, and 7. If you can't divide the top and bottom by 2, 3, 5, and 7, I won't give you a hard time if you didn't reduce it. So let's take 9 over 24. I'm just going to run a quick checklist. Can I divide both by 2? Yeah, I could divide the bottom by 2. 24 divided by 2 is workable, but notice how 9 divided by 2 is not a number that's going to give me a whole, so I can't divide the 9 by 2. So try the next one. If you can't divide by 2, could I divide by 3? Well, 9 divided by 3, yeah, that makes 3. And 24 divided by 3, that makes 8. I can divide both, so go ahead and divide them. So divide the top and bottom by the 3, and now I get 3/8. Am I done? Well, if you're not sure, try those 4 numbers again. Try 2, 3, 5, and 7, and you'll find that you can't divide 3 by any 4 of them, so you're fine. Now, I know I have a feature on my calculator too, usually the ABC button, or you might have a different button, that you could just punch in 9 ABC 24, hit equals, and boom, 3/8 is going to pop out. That's true, and I'm not taking that away from you. But this is a skill you need to know. Being able to reduce fractions becomes more important when there's more than just numbers involved. Now take a look again. 9 over 24 really could be wrote as 3 times 3, because if you remember from a previous video, 3 square equals 3 times 3, which equals 9. And 24 could be 8 times 3. Now what we do is we just get rid of what is the same on the top and bottom. So I have 3 over 8 and 3 over 3. I'll eliminate a 3 on top and 3 on the bottom, leaving me the same 3/8. So basically dividing by 3. More importantly, this works when you have this in Algebra 1. Take a look here. 9a squared b over 24ab cubed. And you're going to be surprised when you find that you're going to be able to do this Algebra 1 that usually it takes people in my Algebra 1 course somewhere around the middle of the year to do. You'll be doing in the next day or so. What you're going to do is an exponent just means multiply. So remember 9 is 3 times 3. A squared is just 2 single A's, and you have your B. 24 is 3 times 8. You have your single A. And B cubed means B times B times B. Remember that anytime they touch, it's times, so they're all times. And this only works, by the way, if you're timesing. It doesn't work if you have plus signs. That is not the same thing. So, cross out the top bottom duplicates. Well, have a 3 here and 3 here, so I crossed it out. Have an A here and A here, I crossed them out. I have a B here and B here, I crossed them out. What do I have left? A 3 and an A, so 3A. And I have an 8 and 2 B's, so B squared. That's what we're doing. And that you don't have on your calculator button, and that's why I'm teaching you this. So don't worry if you didn't follow it all. Just know that if you can do this, you can do this. Yes, this is stuff you've done since 5th grade. This is Algebra 1, which you'll be learning this year. And this is why we practice. So you try. Go ahead and reduce where you can. Reduce it as much as possible, dividing by 2, 3, 5, and 7.
Now go ahead and try these. Go ahead and try to divide down these 5 as best you can. 1 through 4 is what I think you should do. 5 if you're uber special. Go ahead and pause. Let's see how you did. Basically, 9 divided by 27 is going to be a third. 81 divided by 243 will also, when you're done, be a third. 231 divided by 693, oh wow, is going to be a third. And the fourth one, well, let's see. 128 and 132, tricky. I'm going to start by dividing. Yeah, I'll start by dividing by 2. 64, and that makes 66. Divide by 2 again. I get 32 over 33. It looks like I get 32 over 33. And the challenge problem, well, let's see. 16 b cubed over r, 32 b r squared. To break this down, 16 is 2 times 2 times 2, yeah. And then 3 b's and an r over 32, which is 5 2's, a b and 2 r's. Let me change color so you can see it easier. These 4 2's cancel out these 4 2's. This b cancels this b, and this r cancels this r. So what I have left is 2 b's, and I have a 2r. And if you got that, you're doing all right. You're pretty bright. Good job. Last thing. All right, go ahead and pause. Let's see how you do. Number 1, number 2, number 3, number 4, number 5. And the extra credit, if you're that good, will be right here. All right, we'll do a lot of this tomorrow. Thanks again. Bye.
Thanks. See you next time.